Hello, in this lecture we will find the radius of a circle. In the drawing we have a circle. The center of the circle is at point O, and inside the circle we have a rectangle and the size of this line segment is 6 units and the size of this line segment is 3 units. First of all, we will define this point as point M. So line segment CM equals to 6 units, and we will define this point as N. So line segment AN equals to 3 units. In the next step, we will define line segment OM as Y. So actually OM equals to Y. Okay, OM equals to Y, and we will define line segment ON as X. Or line segment OM equals to X. Okay, line segment OM equals to Y, and line segment ON equals to X. This line segment OM equals to X. ON equals to X and OM equals to Y. Actually, line segment CO is the radius of this circle, because of the fact that it starts from the center of the circle, that is to say from point O, and ends at point C, that is a point on the circle itself. For that reason, line segment OC is the radius of this circle. Okay, so I write it down. Line segment OC is the radius of this circle. And also line segment OA is the radius of this circle, for the same reason, because it starts from point O, that is the center of the circle, and ends at point A, that is the point of the circle itself. For that reason, line segment OA is the radius of this circle. Okay, so line segment OA equals to R, the radius of this circle. So because of the fact that both line segments OC and OA are the radiuses of this circle, they are equal to each other. So we can write down that line segment OC equals to line segment OA. Okay, OC equals to OA. That is our first equation that states that OC equals to OA, because of the fact that both of those two line segments are the radiuses of this circle. Okay. Okay, but OC equals to Y plus 6. Okay, OC equals to y plus 6, so we can substitute OC by y plus 6 in the first equation. And also OA equals to x plus 3. OA equals to x plus 3. So we can substitute OA by x plus 3. Okay. So our first equation states that y plus 6 equals to x plus 3. We'll substitute x from equation number 1. So we substituted 6 from this equation. Y plus 6 minus 6 equals to y, and x plus 3 minus 6 equals to x minus 3, because 3 minus 6 equals to minus 3. Okay, so in total we got that y equals to x minus 3 in the first equation. But as I have already told you, the shape OMBM, or the shape OMBN, is a rectangle. For that reason, if OM equals to y, then BN also will be equal to y, because of the fact that the parallel sides in a rectangle are equal to each other. So BN must be equal to OM, because in rectangle AMBN, in rectangle OMBN, OM is parallel to BN and it also equals to BN. So BN also will be equal to y. But according to the first equation, y equals to x minus 3. So we can add here that y equals to x minus 3. Okay. And actually, line segment OB is also the radius of this circle, because of the fact that it starts from point O, that is the center of this circle, and ends at point B, that is the point on the circle itself. For that reason, OB is the radius of this circle. Any line segment that starts from the center of the circle and ends at any point on the circle itself is defined as the radius of this circle, and line segment OB and line segment OA and line segment OC, all those line segments satisfy the definition of a radius. For that reason, they are all radiuses of this circle. So we can write that OB is the radius of this circle. Okay? But OA is also the radius of this circle, and OA equals to x plus 3. So OB, that is also the radius, will be also equal to x plus 3. Again, OA equals to OB, both are equals to the radius of this circle, and OA equals to x plus 3. So OB, that is also the radius of this circle, will be also equal to x plus 3, because both of them are radiuses of this circle. Okay, so actually, as you already know, all the angles inside a rectangle are right angles. They are all equal to 90 degrees, so also angle O and B is a right angle, it equals to 90 degrees. For that reason, triangle OBN is a right triangle. Okay, triangle OBN is a right triangle. And we know that in this triangle, the green right triangle OBN the hypotenuse of the green triangle is x plus 3. This side ON equals to x, and this side BN equals to y, that equals to x minus 3. So the only missing variable in this right green triangle is x. So we actually can use the Pythagorean theorem in order to find out the value of x. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. Or you can write that the square of the hypotenuse, that is to say x plus 3 squared, equals to the sum of the squares of the perpendiculars, equals to ON squared, that is x squared, plus BN squared, that is x minus 3 squared. So we actually implemented the Pythagorean theorem in the right green triangle, and according to the Pythagorean theorem, the square of the hypotenuse, that is to say x plus 3 squared, equals to the sum of the squares of the perpendiculars, equals to x squared plus x minus 3 squared. In the next step, we will open the brackets in this equation, in the second equation. So we actually open the brackets in this second equation. X plus 3 squared equals to x squared plus 9 plus 6x, according to the formula that a plus b squared equals to a squared plus b squared plus 2 times ab, when a equals to x and b equals to 3. And then we have x squared plus x minus 3 squared, and x minus 3 square equals to x square plus 9 minus 6x, according to the formula that a minus b square equals to a square plus b square minus 2ab, when a equals to x and b equals to 3. Okay, so in total we got that x squared plus 9 plus 6x equals to x squared plus x squared plus 9 minus 6x. Actually, in this equation we have x squared in this side of the equation and we have x squared in this side of the equation, so we can cancel x squared, and we have 9 in this side of the equation, and also we have 9 in the other side of the equation, so we can cancel 9. So what left from the second equation is that here we have this side of the equation, we left only with 6x and in the other side of the equation what is left is x squared minus 6x. Okay, that is what left with from the second equation, 6x equals to x squared minus 6x. Now we will subtract 6x from this equation. So we subtracted 6x from this equation. 6x minus 6x equals to 0, and x squared minus 6x minus 6x equals to x squared minus 12x. Because minus 6x is equals to minus 12x. So in total we got that 0 equals to x squared minus 12x. Now we will take a common factor x from this equation. We will take out a common factor x from this equation. So we took out a common factor x from this equation. We got that 0 equals to x times x minus 12. So for this equation we have two solutions. The first solution is x equals to 0, but x equals to 0 is impossible because it is not a correct solution, because x can never be 0. X is the side of this triangle and is also the side of the rectangle, so it can never be 0. It must be a positive number. So x equals to 0 is not a correct solution. And the other solution is x minus 12 equals to 0. Okay, so if x minus 12 equals to 0, then x equals to 12 units. the second solution is x minus 12 equals to 0, because if x minus 12 equals to 0, then anything that you multiply by 0 will be equal to 0, so this will be a solution to this equation, because we will get that 0 equals to 0. Okay, so x minus 12 equals to 0. If x minus 12 equals to 0, then x equals to 12 units. But the radius of this circle is actually x plus 3. X plus 3 is the radius of this circle. So the radius of this circle equal to x plus 3 and we know that x equals to 12 units, so the radius of this circle will be equal to 12 plus 3, that is 15 units. So the answer to the question is that the radius of this circle equals to 15 units. Okay, now I will summarize the lecture. Actually, we wanted to find out the radius of this circle. The center of this circle is at point O, and inside the circle we have a rectangle, and the line segment MC equals to 6 units and line segment NA equals to 3 units. We defined MO as Y and NO as X, and we actually know that OC is the radius of this circle because of the fact that line segment OC starts from point O, that is the center of the circle, and ends at point C, that is a point on the circle itself. For that reason, OC is the radius of this circle. But OA is also the radius of this circle because it starts from the center of the circle, that is to say from point O, and line segment OA ends at point A, that is a point of the circle itself. For that reason, OA is the radius of this circle. So OC is the radius of the circle and OA is also the radius of the circle. So if both of them are the radiuses of this circle, then they are equal to each other. So our first equation is that OC equals to OA because both of them are radiuses of this circle. So, but OC equals to Y plus 6, so we can substitute OC by Y plus 6, and OA equals to X plus 3, so we can substitute OA by X plus 3, and we got the equation that Y plus 6 equals to X plus 3. We substituted 6 from this equation. We got that Y equals to X minus 3. Okay. As I've already told you, inside the circle we have a rectangle. In a rectangle, the parallel sides are equal to each other. So if OM equals to Y, then BN, that is parallel to OM, also will be equal to Y. But we know that Y equals to X minus 3 from the first equation. Y equals to X minus 3. So we can write here that Y equals to X minus 3. Okay? And actually OB is also the radius of this circle because of the fact that it starts from point O, that is the center of the circle, and ends at point B, that is the point of the circle itself. So OB is the radius of this circle because any line segment that starts from the center of this circle and ends at any point on the circle itself is defined as the radius of that circle, and line segment OB satisfy the definition of a radius of a circle. Okay, so if OB is the radius of the circle and OA is also the radius of this circle and OA equals to x plus 3, OB that is also the radius of this circle will be also equal to x plus 3. Okay, so in the green right triangle we know that the hypotenuse equals to x plus 3, this side equals to x and this side equals to x minus 3. So we can use the Pythagorean theorem in order to find out the value of x. According to the Pythagorean theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, x plus 3 square equals to x square plus x minus 3 square. Okay, so this is our second equation. X plus 3 square equals to x square plus x minus 3 square. We solved this simple equation and we found out that x equals to 12 units. Okay, x equals to 12 units, but the radius of this circle is x plus 3. So the radius of the circle equals to x, that is 12 units, plus 3. 12 plus 3 is 15 units. So the radius of this circle equals to 15 units. Okay, thank you very much.